Meet Jonathan Bird, one of the world's top underwater nature cinematographers. Traveling the world on assignment for all the major networks, he is an Emmy Award-winning authority on the underwater world. In freshwater or salt, reefs, wrecks, or caves, Jonathan documents the world beneath the waves. Welcome to the Blue World.
Trivia question. What's 2,000 pounds, bright white, and lives in Connecticut? Give up?
Yes, I'm talking about the beluga whale. And while normally one would need to go all the way up to the Arctic to see one, today I'm going to be hanging out with some belugas at the Mystic Aquarium in Connecticut. The Mystic Aquarium is known for a variety of beautiful underwater exhibits, including their sharks and rays, coral, fish, invertebrates, and even moray eels.
The Barracuda exhibit is really cool, but in my opinion, the best one is yet to come.
The beluga whale exhibit is outdoors. This impressive lagoon really feels like it's out in the wild. It makes visitors almost feel like they're in the water with the whales. Today I'm joining the staff of beluga trainers to learn what's involved in the care of the 4 beluga whales that live here.
That's a lot of fish. Oh, I get the feeling this is gonna take a while.
My day starts with food prep.
Why do segments like this always start with raw fish?
I meet Kate McElroy, one of the beluga trainers who's going to show me how they prepare the daily meals for the whales.
All right, are you ready to start carrying some fish in?
It all starts with herring and squid.
Herring coming up.
Yeah. You can put it right in there as well.
A frozen block of cephalopods. That's actually kind of gross. Look at his little flat eyeball.
You can put that one right up here for me, and I'm gonna make 4 feeds for the day, so this looks kind of complicated here.
Yeah.
But really all it is each bucket that I weigh out for Juno is gonna have 6.3 kilos in it. And for Keela, 2.6, Naku, 5.3, Naluark, 6.4.
Okay, I can do this.
After the fish have been washed and inspected to be sure they're free of any possible contamination, I weigh out a bucket of fish that will be breakfast for a beluga named Juno.
I feel like I'm on dirty jobs.
It is kind of a dirty job, isn't it?
Weighing out the food for all 4 whales takes about half an hour.
Like that's too much. Already. So wrong. So wrong. All right.
Once we finish the messy job of weighing out the fish, we can rinse off our gloves and head out to the exhibit for the next morning task. Outside, the staff is already cleaning the exhibit, and I'm going to help. My first order of business is cleaning the big windows to get all the handprints and dirt off so people can see the belugas clearly. Or maybe so they can see us clearly. I'm not actually sure.
I hope you appreciate this. I'm doing this all for you, buddy.
As I work, Juno keeps an eye on me, and I can't help but think maybe he's not impressed.
Okay, I'm slow at the squeegee. But you gotta admit that that is clean, right? Hey, what do you think you're doing over there? What the heck are you doing now?
So we're gonna move on to the next window. We still gotta get a lot more cleaned.
You want me to actually work?
Yep. So this is a little bit bigger one here.
Big windows mean lots of cleaning, and for some reason I feel like I'm being watched. It's hard to keep my eyes on my work. The whales are incredibly captivating. Next, it's time to scrub the inside of the exhibit to remove the algae that grows on the bottom. The trick, however, is keeping the whales from grabbing the brush and yanking it away from me. Anything that goes into the water becomes something interesting to investigate and possibly play with. For the whales' safety, it's important that I keep them from getting a hold of any of the tools.
Now there's Juno, so that's who we want to pull the pole out if we see. So we'll see.
What are you doing? Oh, dude.
He sensed that you were new, I think.
Uh-oh.
Next, I join trainer Lindsay Nelson, who's preparing to take a weekly blood sample from Naku. This is just a tad more complicated than getting a blood sample from a human. Using a hand signal as a cue, Lindsay instructs Naku to turn around and place her tail up on dry land.
And then I'm going to pull her tail up onto the beach for me on this towel here.
This takes a lot of trust between trainer and beluga because Naku is extremely vulnerable in this position, completely unable to swim.
Right into her vein there, and as you can see, the blood's coming up.
These blood tests are conducted regularly both for research and also to ensure the health of the animals.
After she's done, I'm going to blow my whistle and give her a double tap on her tail, and that tells her she did a great job, and then she knows when she comes back she'll get that fish reinforcement. And then she knows she's coming back for a big fish reward.
Yummy. Is that yummy?
So we do have some capelin.
Yeah.
And
I was
then-
weighing it this morning.
Oh,
That
that's
was
right.
part of my
Yes.
job, yes.
So you probably are.
Later in the day, the trainers provide what's called enrichment. You see, belugas are smart, and they get bored. To keep them happy, they need to be mentally stimulated.
We can also do audio enrichment. So she has a tambourine, you have a tambourine, and then I also have a drum, so different noises for them to hear.
So the idea behind enrichment is basically to do weird and wacky stuff to entertain the whales.
All right, Juno. Here we go. Ready?
With my enrichment hat in place, I put a pole cam in the water to shoot some underwater video. Since divers are not allowed in the water with the belugas, this is my only opportunity for some fisheye views of the whales. The most important part, of course, is to make sure that none of the belugas grab my camera. Although I'm not allowed to go diving, I can go in the water, in a pair of hip waders like a fisherman.
Do you have questions before we get in?
No, let's go. This is my element, baby.
Okay.
Kate takes me into the shallow part of the exhibit where I will learn a few hand signals. The whales know about 100 hand signals. They've been trained to do everything from a raspberry
There you go.
to a breach.
Really? Again?
It's a lot of weight.
Killing me. Nice.
Yay!
The reward? A fish, of course.
Very nice job.
I learn a little bit about Naku's anatomy. She uses her melon, the rounded top of her head, to direct the sound waves for her echolocation system. This is how belugas find food in the wild. Of course, in the wild, she would live in the Arctic around sea ice, which is why belugas are bright white. And if there's one thing to remember, never splash a beluga. They have excellent aim.
There we go. There we go.
Thank you.
I wanted to make sure you got the
But I
pole
did
in.
get a kiss,
And there we go. She's up at you already.
and it only cost a fish.
It's a great kiss. It's like I only did it for the fish.
So I spent a day learning a little bit about beluga whales. They're curious, clever, and full of personality. They're the only whales that can bend their necks to look around without moving their whole body. These are amazing animals, and I feel like I've made some new friends. The Bahamas are famous in the diving world for their natural formations called blue holes. A blue hole is typically a somewhat round hole in the ground filled with water. They're often quite deep. Many Bahamian islands are covered in hundreds of these blue holes. Blue holes were formed during the last ice age when sea levels were much lower than they are today. Rain, combining with carbon dioxide in the atmosphere, creates a mild acid called carbonic acid, otherwise known as acid rain. When rainwater collects in a small depression, it slowly starts eating away the soft limestone of which the Bahamas Islands are mostly made. Over tens of thousands of years, the hole gets bigger and deeper. At the end of the last ice age, as the Earth warmed, the sea levels rose, and with it the water table. The blue holes filled with water. I've come to Andros in the Bahamas to dive a little-known blue hole called Cousteau's Blue Hole. It's called that because Jacques Cousteau himself dove here. My adventure begins at Small Hope Bay Lodge in North Andros. Today I won't be using their dive boats, because we get to this dive site with a truck. Small Hope Bay Lodge dive master Dennis Burrows is taking me on an adventure to a remote area of Andros. We drive through the mangroves to the local highway. Then it's into the forest on a road which appears to be barely more than a trail. A rainstorm passes through, making our journey a little wet. But it just adds to the adventure. Small Hope Bay Lodge owner Jeff Birch has come along to tell me a little bit about Cousteau's Blue Hole. What do we know about Cousteau's Blue Hole here?
Well, what we know is that Cousteau's Blue Hole is one of the very unique blue holes of what I call the round swimming type blue holes, because it's safe to dive from a recreational perspective, not only from a cave structure perspective. And that is very, very unique.
I finally get my first look at Cousteau's Blue Hole. It looks like a small circular pond, but this is no ordinary pond. Some of these blue holes are so deep that before scuba divers started exploring them, they thought they were bottomless. Cousteau's Blue Hole does have a bottom, but it's about 400 feet below. So it's about 4 times deeper than it is wide. The shore around the Blue Hole is mostly limestone, but there are a few muddy places, and cameraman Tim just found one.
Oh, nice!
Get a shot of that! Get a shot of that, Birdman! Oh yeah, I forgot to tell you about that.
Hello!
Unbelievable.
Once Tim has been extricated from the mud, it's time to carry our gear down the path from the road. It's a lot of work, but at least the sun came out. In the golden light of late afternoon, our team suits up and prepares to make a dive before the sun gets too low.
That's good. That's good. This is good. That's good.
Todd takes a powerful set of video lights to help lighting the wall and overhangs. Then it's my turn to get in. Next, cameraman Tim joins us. Dennis will be our dive master. He's done this dive many times and knows where to find lots of interesting stuff. The water at the surface is quite green. Sunlight near the surface allows plankton to grow, making the water murky. And the water is fresh. As we sink deeper, the sunlight drops off quickly, and we turn on our video lights. By 50 feet, there is very little light. By 70 feet, there's almost no ambient light at all. Dennis leads our team along the vertical wall with Todd close behind, lighting the place up. We've reached a layer called a halocline where the fresh water above meets the salt water from the ocean below. In this layer, where oxygen-rich water from above meets oxygen-poor water from below, microbial action creates clouds of fine minerals that float in the water. Dennis leads us to a ledge with a deposit that looks like rusty sediment. Above it on the wall are rusty-looking stains made by iron-oxidizing bacteria. They break down iron from the rock into rust, which falls down and collects on the shelf below. This is the same kind of bacteria that makes rusty stains in sinks and toilets. The deeper we go, the clearer the water gets. At 90 feet, the walls are clean white limestone. At 100 feet, we come across a layer of sediment that looks a little bit like a chocolate layer cake. It's called a microbial mat, and it's made of sulfate-reducing bacteria. These bacteria consume organic material like leaves that fall into the blue hole. They operate in anaerobic conditions, meaning where there is very little to no oxygen. In a sense, this type of bacteria essentially breathes sulfate, which it gets from the calcium sulfate that naturally occurs in seawater. The result is toxic hydrogen sulfide and this thick mat of decomposed organic material. The oxygen level in the water at this depth is very low because it's all consumed by other forms of bacteria that require oxygen to decompose the organic matter in the water. Between that and the hydrogen sulfide in the water, fish just can't survive down here. Soon we start making our way up towards the surface again. In the shallows, algae can live because there's sunlight and no hydrogen sulfide. The algae make oxygen, and fish can live here too, although there aren't many. I managed to find a single fish sitting on a ledge. You have to wonder how fish ever got here in the first place. Because the limestone walls of the blue hole are being slowly but constantly dissolved by the water, it has become quite porous. In fact, if I touch it, it crumbles in my hand like a piece of dried toast. It's hard to believe that solid rock can become so fragile. Just under the surface of the water, less than 10 feet deep, the bottom is completely covered in what looks like an encrusting sponge, but it's not sponge at all. When I touch it, bubbles are released, potentially indicating that there's some type of decomposition going on within it. It appears to be some type of microbial mat that has yet to be identified by scientists. It's hard to believe, but even here in shallow water, there are scientific discoveries to be made. We end the dive at sunset. We've seen some amazing and weird phenomena in Cousteau's blue hole. I would have never guessed there was so much going on in a small blue hole like this one. It just goes to show there's no limit to the amazing things to be seen in the blue world.
Don't go away. Jonathan is about to test his freediving skills with a pod of Hawaiian spinner dolphins.
Dolphins are among the ocean's most exhilarating animals, excitable, playful ambassadors of the sea. Whenever a pod of dolphins appears, I always stop what I'm doing and see if they want to play. Dolphin encounters aren't always easy to plan, but there are places in the world where dolphins are regularly seen. And this is one of those places, the Big Island of Hawaii. Surrounded by the warm Pacific Ocean, the Big Island is an amazing place full of breathtaking views, exotic animals, and volcanic activity. but I've come to meet a pod of dolphins. It's 8 a.m., and Big Island Divers is putting one of their boats in the water at the marina. Cameraman Todd and I grab our gear and head to the boat where we meet Captain Mike.
And we're gonna go look around. I got some spies out right now looking for dolphins, and we'll see what feedback I get from them in the next few minutes.
I listen as Captain Mike explains how he will hopefully find us some dolphins, and then we shove off for the open ocean. Soon we're half a mile offshore, cruising in search of dolphins. Ryan Leinbach, or as we call her, the Dolphin Whisperer, is telling us about the Hawaiian spinner dolphins we're hopefully going to meet.
Hawaiian spinner dolphins live here in the Hawaiian Islands, and at the nighttime they go offshore to hunt and feed in the scattering layer. And so they feed on squid, opelu, that kind of stuff. And then as the sun rises in the morning, the dolphins come back to the shoreline to rest and to socialize along our Hawaiian shorelines. What we're probably going to find today is they're either going to be traveling from point A to point B, or they're going to be in a rest estuary.
So we're cruising just offshore looking for Hawaiian spinner dolphins. And since they tend to rest during the day, they're moving slowly. But they may not be very playful. Soon we spot the dorsal fins of dolphins and we circle closer to see what they're up to.
Okay, so with you guys, timing is going to be critical. Like, when we say go, you go. These guys are turning around right here. That's what we want. We want them to stay here.
The dolphins look pretty active, so now is my chance to suit up and see how close I can get. I'm ready to go. Ryan slips silently into the water with me and Todd close behind. At first we don't see anything, but then the dolphins come into view. They make a fairly close pass to have a look at us, then they turn and swim away. I swim along behind them for a few minutes, but eventually they give me the slip. But that's okay. If there's one thing I've learned about interacting with dolphins over the years, it's that you need to be patient.
Whew. Well, that wasn't bad for a first try. It was interesting to see them in the water, but they just weren't interested in playing.
We pull the ladder and head off to find a more cooperative pod. Captain Mike has found another pod. Behind the boat, they're doing what spinners are known for: spinning. So we slow down and get ready to try again.
Hopefully this is gonna be it.
Yeah. Once again, I drop into the water with my camera and fin my way over towards the dolphins. Soon, Todd and I are in the middle of a big pod of spinners. I do my best dolphin impersonation, freediving down to them as they pass below. But they make my breath-holding skills look pathetic. This group is going slowly because they're actually resting. They hunt at night in deep water, so during the day they rest. Dolphins don't rest the way we do. If they fall asleep, they'll drown. When a dolphin sleeps, it shuts down half of its brain, while the other half stays awake, controlling a slow swim and periodic breathing. After a while, the dolphin swaps sides, letting the other half of its brain sleep. The result is a slow swimming animal that appears fully awake, but not really. Spinner dolphins are not particularly large. They grow to be about the same size and weight as an adult human. But they don't live as long. Estimates are that they only live to be about 20 or so years old. So, after a short but exciting encounter with these majestic and beautiful animals, I watched them swim off into the blue. They need their sleep for tonight, hunting somewhere out there in the deep blue world.
Meet Jonathan Bird, one of the world's top underwater nature cinematographers. Traveling the world on assignment for all the major networks, he is an Emmy Award-winning authority on the underwater world. In freshwater or salt, reefs, wrecks, or caves, Jonathan documents the world beneath the waves. Welcome to the Blue World.
When I was a kid, I dreamed about exploring the oceans from an undersea lab far away from the distractions of the world above. Now that might seem like a science fiction fantasy, even less likely than a space station.
As it turns out, a bunch of scientists and engineers thought an undersea lab might be a great way to study the ocean and life in the ocean. With funding from the National Oceanic and Atmospheric Administration, they created the Aquarius Reef Base near Key Largo, Florida. My childhood dream has become a reality. Here, 6 people can live and work for weeks at a time without ever going to the surface. Sure, it seems really cool, but to truly understand how this underwater habitat benefits the study of the ocean, you really need to understand a little bit about the physiology of scuba diving. Scuba gear has given humans the ability to explore the shallow parts of the ocean. We can hover weightless like fish, breathing underwater for as long as our scuba tank lasts, which is generally about an hour.
But even with an unlimited scuba tank, we can't stay down too long because of something called decompression sickness, or the bends.
When I submerge underwater, the increasing water pressure at depth pushing in on my lungs won't allow me to breathe unless my regulator supplies air to me at the same pressure as the water around me. The deeper I go, the more water pressure there is, and therefore the air I'm breathing is at a higher pressure too, pushing out at the same pressure as the water pushing in. Since about 79% of the atmosphere is composed of nitrogen and our bodies can't metabolize nitrogen, all this high-pressured nitrogen builds up in my muscles and other tissues when I dive. If I stay underwater for too long, too much nitrogen builds up in my body.
When I come up to the lower ambient pressure at the surface, it can form bubbles in my blood, sort of like this. Those bubbles get stuck in arteries and veins, blocking circulation and causing great pain. But what if I didn't have to come back here to the lower ambient pressure at the surface after a dive? What if I could stay at a high ambient pressure by living in an undersea lab? Well, I could scuba dive all day long and I'd never get the bends. That's the idea behind the Aquarius Reef Base.
The Blue World team has been invited to film an Aquarius mission, so cameraman Tim and I have come to beautiful Key Largo, Florida for an adventure. We load the Aquarius support boat and join the staff as we depart from the dock for a 45-minute ride out to the Aquarius. Once we clear the canal and reach the ocean, we still have a few miles to go. The Florida Keys have huge areas of shallow coral reefs before the seafloor drops off into deeper water. So, Aquarius is located a bit further from shore than you might expect. Our ride takes us over miles of beautiful coral reef. I can hardly contain my excitement to see this astonishing underwater habitat. At last, we reach the life support buoy. This floating structure contains generators and compressors supplying power and air to Aquarius below. We tie up our boat to the life support buoy. Aquarius is sitting on the sea floor 60 feet beneath our boat. Tim and I suit up and prepare to not only see Aquarius up close, but go inside and meet the team of divers called Aquanauts with whom we'll be working for the week.
Well, I'm all geared up and ready to go. This is so cool. You have got to see this.
As soon as I hit the ocean, I can see Aquarius directly beneath me in the clear water. It's almost like a submarine that doesn't move. But unlike a submarine, the pressure inside Aquarius is the same as the pressure outside. So even though there's an open hatch at the bottom of the habitat, water doesn't go in. This allows people to go in and out of Aquarius as much as they like.
Which is totally awesome! So this is it, the Aquarius. Amazing. I can come right in through an open hole in the floor, and yet the water stays out. That's cool. Now, time for a shower. You have to shower before you go inside the Aquarius because really they don't want salt water and everything. I mean, we might be underwater, but this is civilized. So the Aquarius, you can think of it as basically like a big school bus with no seats in it. It's sort of like a long tube, and everything is spread throughout that tube. At this end, behind this power door, is the front porch, and that's where I came inside. We like to keep that closed because it's quite humid in there, and it's air conditioned in here. Now the next feature you'll find right inside the front door here is the bathroom. There's your bathroom. You get your privacy curtain. You know, it's a pretty small bathroom, but gets the job done. And of course, right across over here, a sink. And of course, some laboratory equipment, you know, just in case you need to do some biological studies. And then we come down a little further. We have a computer. Well, you got to be able to get on the internet even when you're underwater. I mean, come on. So here in the middle of the Aquarius, we have the kitchen, or what you would call on a boat, the galley. So if you come in here, we've got the sink, and we have a sort of a place to eat, a kitchen table, if you will, and a picture window. But unlike your picture window at home, this picture window looks out on a coral reef with fish swimming by. Where's the fish? Come here, fishies. And the last part, down here at the far end, this would be sort of like the back of the school bus. You have 6 bunks all stacked up together. You can see there's not a lot of space in here. In fact, if you're sleeping, you only have about 1.5 feet from your head to the next bunk up. It's pretty tight, but it's cozy and it's dry.
And you can't beat the view out the window at the foot of the bed.
So now you might be wondering, what do you eat down here? Well, they eat sort of like astronauts. It's freeze-dried food. If you're a camper, you might have used some of this stuff. You rip the package open, you put hot water in it, you let it sit for a while, and then you can eat it right out of the package. They don't really have a lot of facilities for cooking. They have a microwave and they have hot water, and that's about it. There's no stove, there's no oven. Some of the food that gets brought down in very tight containers gets compressed with the pressure down here. So this is something that was fully inflated at the surface, but once it gets brought down here to 50 feet, the pressure in here squishes it down, and that's what it ends up looking like. And you can feel the pressure all around you, even though you don't really feel like you're under pressure. The air that we're breathing is a little bit more dense because it's compressed. And several things happen. My voice sounds a little funny to me, but on top of that, it's really hard to whistle. There we go.
Even though the scientists are out scuba diving, there are always 2 technicians in Aquarius maintaining the life support, fixing little things that break, monitoring the various systems, and keeping track of the divers. While technician Mark Hulsbeck is giving me an introduction to the life support systems, we're being watched by someone on shore. There are cameras all over Aquarius. They send their signals through a cable up to the life support buoy, where the signal is beamed wirelessly back to the antenna on shore. Here at the watch desk, another technician monitors activity, electrical systems, and life support. This is an additional layer of safety. If there's some kind of emergency, help will be on the way immediately. Meanwhile, down at Aquarius, I have to leave. I can only stay a little more than an hour because I have to return to the lower pressure at the surface or I'll have decompression sickness. The biologists, however, are out working on the reef conducting their study of reef sponges. They wear double scuba tanks so they can carry a lot of air. Even though they dive 100 feet deep, they can spend hours and hours doing their research, utterly unconcerned about such trivial things as decompression sickness. They can spend as much time as they like on the reef because they don't need to go to the lower pressure of the surface after the dive. Instead, these aquanauts will return to Aquarius. When their scuba tanks get low, the aquanauts head over to the nearest gazebo. It's sort of like an oasis for divers. It's filled with air. Inside, they can take their masks off, talk to each other, and fill their scuba tanks from a high-pressure hose from Aquarius. After an air fill, the aquanauts can go back out on the reef for a few more hours. Eventually, though, they get hungry and come back to Aquarius for lunch.
The scientists are still down there. It's hard to believe they can stay for a whole week, but I can only stay for an hour.
The next day, I have another hour to spend in Aquarius, so I go during lunch to meet these sponge-studying aquanauts.
What is it that you can do here that you can't do from the surface? Now, why do you gotta go through all this?
We have about 6 different projects going on right now, but one of the largest projects is that we go to the same sponges every year, and we have, each one has a tag, so we know which one's which, and we go back and we see which ones are alive, how well they're doing, and really that we have over 900 sponges that we visit every year, and it just takes so long that we really need a lot of bottom time. And like this morning we did a 6-hour dive and we did, I think, 1 plot, but if we were to do that from boats from the surface, that would have taken us probably 6 to 10 dives.
After lunch, the aquanauts gear back up and head out for another few hours' work. They may swim quite a ways to their research site, but they have safety lines to lead them back home to Aquarius. Aquarius isn't just a home for aquanauts. Over the years, coral and sponges have grown all over the structure. It's been transformed into an artificial reef with thousands of fish taking up residence. They're all used to divers. One of the resident tarpon comes right up to my camera for a close look. cameraman Tim investigates a purple coloration on the hull of Aquarius, only to be attacked by an angry Sergeant Major, a kind of damselfish. The purple coloration is an egg nest. The tiny eggs are stuck to the hull by the female and guarded by the male, and he's not happy. Aquarius is home to fish as well as people. While the marine residents have all they need, the humans inside need constant supplies from the surface. Drinking water is brought down each day by surface support divers. Air gets pumped down all the time by the life support buoy overhead. It continually overflows out the bottom of the wet porch so the air inside stays fresh. If the pumps in the life support buoy failed, there's a huge supply of air in reserve tanks next to Aquarius. Getting dry things like food, cameras, and towels down to Aquarius presents a bit more of a challenge, but the team came up with a brilliantly simple solution. It looks like a giant pressure cooker.
So this is a modified paint pot. So they apparently don't use them anymore. They don't make them.
This heavy steel container has a valve on top for equalizing internal pressure and 8 strong clamps to keep it closed.
So when we close the valve up top, shut everything down, tighten it down all these dogs all the way around. Yeah.
Depending on how heavy the stuff inside is, a diver may be able to handle it alone, or an air-filled lift bag might be required to keep it from sinking. Once the pot is delivered, the valve is opened to bring it up to the same internal pressure as Aquarius, and the clamps come off. With any luck, everything is dry. In the last 10 years, only one has leaked.
Thank you, Brad.
You're welcome, Otter.
At the end of their week in Aquarius, the aquanauts must go through one long decompression to bring their bodies back to surface pressure. They rest for about 18 hours, watching Blue World DVDs, of course, while the pressure inside Aquarius is brought back down to that of the surface. For a few hours, they wear masks and breathe pure oxygen. Aquarius serves as one huge decompression chamber. In spite of all the effort required to keep Aquarius running, this underwater lab is actually not very expensive to run, about $10,000 per mission day. That might sound like a lot, but it's actually inexpensive when the number of diving hours are all added up. 4 scientific divers can rack up 32 to 40 combined hours underwater each day. We know very little about the oceans just because they're so difficult to study. But we do know that the oceans are incredibly important to our planet, our atmosphere, and all life on Earth. The more we know about the oceans, the better we can protect and nurture the entire Earth's environment. Aquarius Reef Base is the world's only underwater research station serving on the front lines of cutting-edge ocean research. And with continued funding, it will be helping scientists study the ocean for many years to come.
Don't go away. Jonathan is about to explore the incredible world of skates and rays.
You know me, I love sharks. It doesn't matter if it's a big shark like the great white or the whale shark, or if it's a small one like the white-tip reef shark. Sharks are cool.
Skates and rays are the evolutionary cousins of sharks. They're contained within the same class, Chondrichthyes, along with the sharks, but they're in their own subdivision known as the badoids.
The badoids share many characteristics with sharks, such as the cartilaginous skeleton, the lack of a swim bladder, and multiple gill slits. In fact, they're so similar that you almost could think of them as flat sharks. But there are some flat sharks. The wobbegong shark, for example, actually looks more like a ray than a shark because it's flattened and tends to lie on the bottom.
So how do you tell a ray from a flat shark?
First of all, skates and rays are always flat. Biologists call them dorso-ventrally flattened. But unlike a dorso-ventrally flattened shark, a skate or ray has wing-like pectoral fins that are just an extension of its body, making it look a bit like a flying carpet. Or maybe if you squint a little, a bat, hence the name batoids. Also, skates and rays have their gills on the underside of their bodies, while a shark, even a flattened shark, has them on the side. One of the most well-known rays is the stingray. This is a southern stingray common in the Caribbean. It gets its name from its stinger, a sharp, venomous spine at the base of the tail. This powerful weapon is used to defend the animal from its most feared predator, sharks.
Wait a minute! Sharks eating their own evolutionary cousins? That is so uncivilized.
The southern stingray feeds on animals that live in the sand, like mollusks and worms. The stingray's mouth is on its underside, just like its gills. It blows water into the sand to excavate around prey, then slurps it up with powerful suction. Because it feeds in the sand, the southern stingray tends to swim close to the bottom, though it certainly doesn't have to. But this poses a problem with breathing.
A shark breathes by taking water in through its mouth and then sending it back out through the gills to extract oxygen from the water.
However, since the stingray has its mouth on its underside and swims so close to the bottom, you would think that the stingray would get a lot of sand into its gills. And you would be right, except for one thing. On top of the stingray's head are a pair of openings called spiracles. They're kind of like big nostrils. Instead of breathing in through its mouth, the stingray breathes in through the spiracles on top of its head and away from the sand. Sharks have spiracles too, but they're really small on most sharks and they can't breathe through them. The only sharks that breathe through their spiracles are, you guessed it, flattened bottom dwellers like the wobbegong. Notice how this ray swims by flapping its wings and gliding along just over the sand. By comparison, meet the little skate, common in the waters of New England. It looks just like a miniature stingray, but it's a skate because it has no stinger. Although it can swim by flapping its wings, it often scoots along the bottom by repeatedly pushing off the bottom with its pelvic fins. Kind of like riding a skateboard. This type of locomotion has been termed punting. Most batoids have pelvic fins like this, but only a few use them to move in this way.
And if you think that's weird, check out this strange-looking ray.
The torpedo ray doesn't look much different from any other ray when it's lying on the bottom. But when it gets up to swim, it has a vertical tail fin like a shark. Instead of flapping its wing-like pectoral fins, it swishes its tail back and forth to swim. And that's not even the weirdest thing about this unique ray. The torpedo ray is also known as the electric ray because it can produce 50 volts of electricity to shock its prey. Most rays can't electrocute their dinner into submission. The spotted eagle ray spends a lot of time soaring through the water like the eagle for which it's named. But look closely. It has a shovel-shaped face for digging around in the seafloor. It's a bottom feeder, just like the stingray.
And look here! Not just one, but 3 stingers!
Another ray that likes to swim up off the bottom, the manta ray. If ever there was an animal that looked like a flying carpet, this is it. Unlike most other rays, this animal eats plankton. It swims through the water with its mouth wide open, allowing the tiny plankton to go into its mouth and get stuck on comb-like filters on its gills. Then it swallows them down. Mantas don't have spines for protection. They rely partly on their large size to deter predators. But they can jump pretty far out of the water to escape predators too. Sometimes that doesn't help. This manta has a bite cleanly taken out of it by a shark. Ouch, that's gotta hurt. It probably happened when this ray was much smaller. Manta rays are ovoviviparous, meaning that they produce eggs that hatch internally. Baby manta rays emerge from their mother alive and swimming. All rays use this reproductive strategy. However, skates, like the little skate, are oviparous. They lay eggs. This is the egg of a skate. The mother produced 5 to 15 of them. They're laid on the sand and given no parental protection. Inside the egg, a baby skate develops for up to a year depending on the water temperature. Finally, the day comes when the baby skate slowly forces its way out of the egg case and swims away. Even a newborn knows to camouflage itself quickly to avoid predators. Skates and rays are a diverse group. Not all badoids look like the typical ray. This animal's called a saw shark or sawfish. It looks more like a shark, but it's a ray. Don't believe me? Where are its gill slits?
A shark's gills would be here, but they're underneath. And look, it's breathing through large spiracles.
The sawfish uses its saw to hunt by swinging it back and forth in the sand, impaling soft-bellied creatures on the teeth. So, skates and rays are a diverse group of animals with many adaptations to survive. And while they're not as well known as their cousins the sharks, they're every bit as fascinating.
Meet Jonathan Bird, one of the world's top underwater nature cinematographers. Traveling the world on assignment for all the major networks, he is an Emmy Award-winning authority on the underwater world. In freshwater or salt, reefs, wrecks, or caves, Jonathan documents the world beneath the waves. Welcome to the Blue World.
Most people, when they think about the Bahamas, imagine sandy beaches, blue water, and colorful coral reefs. What they generally don't think about is this: limestone. The Bahamas are islands built on a base of limestone, the skeletons of ancient coral reefs accumulated over millions of years. Bahamas limestone often looks like Swiss cheese because over thousands of years, slightly acidic rainwater has dissolved holes in it. Sometimes those holes get quite large and fill with water. Hence, they become what are known in the Bahamas as blue holes. Many of these blue holes have amazing cave systems within them. The Blue World team has traveled to the island of Andros in the Bahamas to explore one of the most famous blue holes in the world, Stargate. Our home away from home? Small Hope Bay Lodge on North Andros. They have a beautiful beach, an idyllic tropical location for rest and relaxation. Hey, I'll admit it, I don't mind Blue World assignments in the Bahamas. I might even just take a little nap in a hammock outside the dive shop. But not for long, because I have a meeting with Jeff Birch, the owner of Small Hope Bay Lodge, who's taking us diving.
So Jeff, tell me, where are we going for this dive?
Well, we got to get down here to South Andros, to Congo Town, because Stargate is just south of that. And of course, these bites go all the way through the island. So what we're going to do is we're going to leave Small Hope, which is right here. We're going to drive to the airport, and we're going to jump in the plane, and then we're going to fly on down here, all the way down, crossing the bites. You're going to see some blue holes along the way, straight to Congo Town.
How long of a flight is that?
Yeah, about 25 minutes. And then after we get here, we'll offload and we'll catch a ride up to Stargate.
Sounds great. I can't wait.
Oh man, it's going to be great. Absolute adventure. It's going to be great.
Early the next morning as the sun rises, cameraman Tim, Todd, and I get our gear ready for an early departure. We have a long day ahead, and it starts with a ride to the airport in the back of a pickup truck loaded with gear. At the airport, we come to the conclusion that we have way too much gear to cram it all into a Cessna 172 along with ourselves, so Jeff decides to make 2 trips down south. We load all our scuba gear into the plane along with cameraman Tim for the first trip.
Good to know you.
Well, thanks for dropping us at the airport and leaving us here.
Hopefully, Jeff will be back for me and Todd, and the camera gear, in an hour or so. Jeff is a man of many talents. Not only is he the owner of Small Hope Bay Lodge and a dive instructor, but he's also a pilot with over 40 years' experience flying around the Bahamas. When you run a hotel in a remote place like Andros, an airplane is practically a necessity. For Jeff, his airplane is like a car to many people. He and cameraman Tim are off on the first leg of our adventure, delivering the scuba gear to South Andros, which is only accessible by plane or boat. But it's too far by boat for a single day. So, in spite of a strong breeze, flying is the only practical way to reach Stargate. The 25-minute flight takes Jeff and Tim over the beautiful and remote landscape and coastal ocean of Andros Island. Soon they land on South Andros. At the Congo Town airport, they unload the scuba gear from the airplane. That's a lot of gear for a small plane. But Jeff does this kind of thing all the time. It's part of being a bush pilot. Soon he's back in the air, on his way back north to pick up me and Todd. We're just sitting around at the North Andros airport watching the clouds roll in and wondering what the weather will bring. It's looking a little ominous. Jeff lands under a graying sky and the first droplets of impending rain. We load the rest of the gear and we're off. Looking out the window, I can see the Guardian Blue Hole, where we dove last time we visited Andros. But then things get a little exciting. We head directly into a huge rainstorm. Rain is pelting the airplane. We can't see anything out the windshield. I've seen better visibility underwater. Fortunately, it's not long before we land safely in South Andros to meet up with cameraman Tim.
Man, that was a wild ride.
With all of our team and gear finally in South Andros, we can load it all into a van and head out to Stargate. I'm not sure exactly what I was expecting, but Stargate turns out to be practically in the middle of a neighborhood near Congo Town. It even has a sign. We park the van as close as we can, and Jeff points out an interesting formation.
That's it. Stargate fault line right there. See it?
Jeff is pointing out a crack in the limestone, sometimes called a fault or a fracture. It's actually part of a series of fractures stretching more than 10 miles, formed during the last ice age when sea levels were lower and stresses within the rock caused some of it to break. Deep underground, this fracture is filled with water, and we're about to dive inside it.
Look, I'm spanning the fault. It's
Very impressive. Well, you're not impressed now, but you wait. You will be impressed when we're diving under it. But before we can dive, we still have another task ahead of us, hauling all the gear to the Stargate entrance.
All right, good. Are we ready to rock and roll? Let's carry. I still got another hand. Here, I'll take another leg.
I carry this from the...
All right.
Here, right? Sure.
And you know what that means, hoofing it on foot through the forest.
Halfway.
It's not a long walk, and there's a clear trail, but you can really appreciate how heavy scuba gear is when you have to hike it through the woods. Hiding in the forest, the entrance to Stargate offers up a little surprise. The water is more than 20 feet down inside the hole. Jeff gives us a dive briefing and goes over how we will conduct the dive.
We're going to go down, and then it's fresh water here, and you have the mixing zone.
Having limited access to the water, we have to lower our gear down on ropes. It's not the gear I'm worried about, it's me. Once the gear is down, we start suiting up for the dive. It's been a lot of work to get this far, and I can't wait to see what Stargate has to show us.
Voila. Sir, my pleasure.
I appreciate it. Mucho. This is Fetty's gear.
So you're going to demonstrate the proper technique to throw yourself off this cliff.
Throw.
And survive. Survive.
Yes.
The near death-defying height.
I will try.
Okay. Did he survive? Yay! He's alive!
After Jeff shows us how it's done, Todd goes next. Lowering my expensive underwater camera and lighting system down into the water with a rope makes me more than a little nervous.
This is the most ridiculous way to put a camera in the ocean.
After Todd grabs my camera for me, it's my turn to jump in. I'm a little excited and a little nervous, but there's no turning back now. It's actually pretty fun. But I'm not sure how we get back out. Cameraman Tim joins us and we start heading down through the greenish water. Jeff leads us down into the weird, swirly halicline, a layer where the fresh water at the surface mixes with the salt water below. Jeff points out ancient coral, clearly identifiable. This is the stuff that makes up most of the limestone on the island. As I examine the limestone carefully, I can clearly see star coral and brain coral. The overhanging walls of the cavern are covered in flowstone and stalactites. Todd backlights a stalactite to show its shape. Flowstone is a type of formation formed by flowing water in a dry cave, leaving behind delicate limestone formations that look like molten wax on the side of a candle. This formation took thousands of years to form. We follow Jeff into a crack in the wall at about 80 feet. As we go deeper, the water gets clearer and clearer. There's a safety line for us to follow if we need it. It points the way out if we get lost or lose our lights. Todd is swimming ahead of me, lighting up the cave with powerful LED lights. Looking down, I can see the bottom of the cave at 100 feet, but as we progress down this narrow passageway, the bottom is dropping out of sight. It drops to 200 feet, way too deep for us today. We stay near the top of the passageway to keep as shallow as possible. The walls of the cave are decorated in all directions with beautiful and delicate flowstone. The whole place looks like an ornately decorated wedding cake covered in frosting. It's hard to believe that during the last ice age, when sea levels were much lower, this massive chasm was dry and filled with air. Dripping water from rain up above made all these fantastic decorations. Todd stops to point out a huge flowstone formation. I've never seen anything like it. Everywhere I look, my jaw drops, and I'm actually having a hard time knowing where to point my camera. Next, we swim into a huge space where the walls bow outward. The water is so clear that the divers look like astronauts hovering in space. Only their bubbles betray the presence of water. Remember that crack in the ground up above? Well, right now, our dive team is about 120 feet directly underneath it. That tiny little fault line I stood across opens up into this massive submerged chasm. Soon we approach the end of the tunnel. We reach a place where the rocks have fallen in and blocked the passageway. This is where we turn around and head back. As we head back, the water is filled with sinking particles dislodged from the ceiling by our rising air bubbles on the way in. This is an excellent time to concentrate on filming close-ups of the delicate formations on the wall, such as these exquisite stalactites that look like icicles of stone. Jeff points out an incredible flowstone formation that Todd helps me film using his lights. This formation is so thin that light passes through it like a lampshade. Have you ever seen a rock so thin that light passes through it? Because it's thin, it's very fragile. Todd is careful not to actually touch it. That is so cool. Soon we reach the entrance and make our way out of the fault and back into the cavern where the water is green. We ascend slowly back up through the swirly halicline. We stop at 20 feet where we must undergo 15 minutes of decompression before we can surface. Daylight is tantalizingly close. At last we surface, thrilled with an amazing dive. And now, all our gear has to be hauled back up on a rope. Getting ourselves out of the water is another trick altogether.
That was one of the most amazing dives of my entire life. But unfortunately now I have to climb this to get out of the water. All right.
A wooden pallet and a thin rope holding it in place comprise my ladder to freedom. I just hope this rickety contraption doesn't break.
Well, this isn't too bad.
and just climb out. That has got to be the most work I've ever done for a dive, but it was so worth it. It was totally worth it. Oh, I feel like a goat.
So the Blue World team spent the whole day hauling gear by airplane, truck, and foot to reach this remote hole in the ground. It doesn't seem all that special from the surface, but the dive showed me an incredible world of delicate flowstone formations inside a massive chasm filled with crystal clear water. Quite simply, magnificent. Every time I think I've seen it all, I see something new like this and realize there's a lot more to discover in the Blue World.
Don't go away. Jonathan is about to shed some light on one of the simplest sea creatures, the sponge.
When people think of a sponge, they usually imagine something like this. A cleaning sponge for washing the dishes. Or for washing the car. Cleaning sponges are synthetic these days. But they used to come from the ocean. Back in the days before we had synthetic sponges for housework, cleaning sponges did come from the ocean. They were harvested by hard hat divers walking along the ocean floor in heavy weighted boots with a rake-like tool to pluck the sponges off the bottom. It was a dangerous and difficult job. Bagfuls of sponges were lifted to the boat above. Immediately, the crew set to work cleaning the sponges. Then they were hung to air dry. After days or weeks at sea, when the boat was full of sponges, they were taken to shore where they were auctioned to the highest bidder. Finally, they were trimmed, sorted, and sold to the public. Natural sponges are still harvested in nearly the same way today, but the synthetic sponge has spared the lives of countless ocean sponges. While an ocean sponge looks something like a weird plant, it's actually an animal. In fact, sponges are among the simplest multicellular animals on Earth. They live on the bottom of the ocean, attached to a surface and never moving because they can't walk or swim. Some are quite colorful, while others are drab. They also come in all shapes and sizes. There are tube sponges, vase sponges, barrel sponges, rope sponges, encrusting sponges, and many other types. Sponges live from the frigid waters of the Arctic and Antarctic to the tropics. On many coral reefs, sponges dominate the seafloor and the drop-off. One of the most common sponges on coral reefs is the barrel sponge. Barrel sponges grow to epic proportions, getting larger than a person. Although sponges can't walk or swim, they can feed. They do it by filtering tiny plankton from the water. A sponge is covered with small pores called ostia, which lead to a system of internal canals and eventually out to one or more larger holes called oscula. Within the canals of the sponge, chambers are lined with specialized cells called choanocytes or collar cells. The collar cells have a sticky funnel-shaped collar and a hair-like whip called a flagellum. The collar cells serve two purposes. First, they beat their flagella back and forth like fans to move water through the sponge. The water brings in nutrients and oxygen while it carries out waste and carbon dioxide. Second, the sticky collars of the collar cells pick up tiny bits of planktonic food brought in with the water. Sponges are very effective filter feeders since they're able to capture and eat particles as small as bacteria as well as larger particles. They might not look like they're doing much, but a simple demonstration shows how effectively sponges can pump water. On a reef in the Caribbean, I make a dive with a syringe filled with a non-toxic dye called fluorescein. By squirting it around the base of some sponges, we can observe how the water is moving by watching what the dye does. Within only seconds, the dye is pumped through the sponges along with the water. As you can see, a sponge is a pretty good water pump and also a good strainer. Any plankton that goes in with the water won't come back out through the osculum. Tube sponges are even more spectacular to observe. They pump the dye so furiously that they look like a collection of miniature smokestacks. The ultimate test is a hefty barrel sponge. What will a big monster like this do? It takes a few seconds for the dye to work its way through the sponge. Wait for it. But then it pours out like smoke from a chimney. That's pretty good pumping from those tiny little collar cells. Since sponges can't get together to reproduce, they spawn in a way similar to coral. The sperm is released into the water column by the male sponge. It finds its way to the female sponges where fertilization occurs internally. Eventually, the planktonic larvae are released from the female sponge and float around in the water column as plankton for only a few days. Then they settle down and start growing. Sponges don't have many predators. There's not much nutritional value in a sponge, and they're hard to digest. Hence, very few animals can eat sponges. But something was clearly eating this sponge. A sea turtle is the culprit. Sea turtles are one of the principal predators of sponges, along with a few species of fish and some invertebrates like nudibranchs. Sponges might not be very exciting, and they certainly don't have much personality, but they're an ancient animal that has been living in the oceans for at least 500 million years. They can't crawl around or swim, but they're very good at reproducing and feeding themselves by pumping water. So, chances are sponges will continue to populate the oceans longer than people will populate the Earth.
Meet Jonathan Bird, one of the world's top underwater nature cinematographers. Traveling the world on assignment for all the major networks, he is an Emmy Award-winning authority on the underwater world. In freshwater or salt, reefs, wrecks, or caves, Jonathan documents the world beneath the waves. Welcome to the Blue World.
The white-tip reef shark. It's one of the most common small sharks on reefs all around the Indo-Pacific. Considered largely harmless, this shark is usually seen by divers lounging on the bottom.
But how does this shark eat when it seems to spend all of its time sitting around?
To answer that question, I'm getting aboard a special dive boat in Costa Rica for a 300-mile journey to Cocos Island. Cocos Island is a tiny dot on the map out in the Pacific Ocean. The only way to get there is a 30-hour boat ride. We leave the dock in Punta Arenas, Costa Rica, and travel through the bay to the open sea. The swell of the Pacific soon envelops the boat, and I settle in for a day and a half of waiting. Finally, we reach Cocos Island, a place that gets more than 12 feet of rain in a year. A sunny day like this is rare indeed. But all that rain has created a tropical paradise. Cocos Island and the water around it is a national park of Costa Rica. It's uninhabited and protected from development. My home away from home for the week is the 130-foot-long liveaboard dive boat, Argo. Our team will be diving from a smaller boat, which the crew launches with a crane. I head out for a dive at Cocos, famous for its prolific marine life that will impress even the most experienced divers. Our dive boat captain Pepe takes us to an exciting spot known for sharks. As soon as I hit the water, my camera's rolling, recording astonishing sights in all directions. The most famous residents of Cocos are schools of scalloped hammerhead sharks. They're quite shy, rarely coming too close to divers because the bubbles frighten them. I hide behind a rock and make an attempt to film the hammerheads as they slow down to be cleaned by barberfish. In the water above the sharks, huge schools of jacks swirl by in the current. And sitting on the bottom, not doing much, white-tip reef sharks, lots of them. Some tolerate my camera at close range while I film how they gulp water to ventilate their gills while they rest. During the day, they spend a lot of time resting. But don't let this apparent lethargy fool you. These little sharks are hunters. As the sun sets, a transformation occurs on the reef.
That transformation takes place when daytime fish go to sleep for the night, hiding in the reef, and the sharks go on the prowl.
After sunset, I gather my gear and head out to make a dive.
I'm about to jump into the ocean in the middle of the night when I know for sure that there are dozens of sharks beneath the boat.
As soon as I reach the reef, I see white-tip reef sharks swimming around. None of them are resting anymore. While white-tip reef sharks do normally feed at night, here at Cocos Island they've learned an additional skill. they use divers' lights to help them feed. So the sharks are drawn to my video lights. Within a few minutes, dozens of sharks are swarming the reef around me looking for food. During the day, this reef has vast schools of fish on it. At night, all those fish are still here. Most are holed up inside the reef sleeping. But this Creole wrasse is sleeping right out in plain view of the sharks. Is it in trouble? A bright blue parrotfish sticks out like a sore thumb, yet the sharks swim right by without noticing. What's going on? Since the sharks normally hunt in the dark, they're much more attuned to their other senses and principally hunt by feeling vibrations through the water from the prey. In other words, if the prey doesn't move, the sharks may not ever see it. A filefish hovers as still as it can. It knows it's in a dangerous position. When a shark bumps it, the filefish slowly moves away. But the shark felt it and comes back around to investigate. A gentle tap with its snout and the shark knows it's onto a meal. Once the fish gets frightened and bolts, all the sharks sense the vibration and start chasing the fish. It's a free-for-all. The fish knows its only chance is to vanish into a hole in the reef beyond the shark's reach. It makes a dash for the reef, but it's too late. Another filefish bravely holding still in open water, surrounded by sharks. But the sharks do see this one. The fish tries to slowly sneak down to the reef, but doesn't make it. Meanwhile, the parrotfish is still hiding in plain sight. But one of the sharks has either seen it or detected its beating heart with its electrosensory system. The shark nudges the fish for a reaction. The fish bolts and a chase ensues. I follow along to see what happens. The parrotfish is desperately trying to find a place to hide. It dives into the reef, but the sharks pursue the fish relentlessly. They will wiggle their way into a tiny hole to grab the fish, sometimes knocking over the coral in the process. Every one of these sharks is hungry and must eat to survive. Eventually, two sharks get in from the other side, fighting over the parrotfish. The fish is dinner. After an hour of excitement watching the sharks hunt, my air is getting low, and it's time to head back towards the surface. As I reluctantly ascend, I get a wider view of the scene playing out below. I would hate to be a fish on that reef.
Whoa! It turns out white-tipped reef sharks aren't lethargic at all. At night, they're extremely aggressive hunters. Get me out of here!
This is Harold Parker State Forest in Massachusetts. It looks like a typical forest, but not all forests are the same.
I'm heading to Catalina Island off the coast of California to explore another kind of forest.
Here the forests are underwater.
Getting here from the mainland is as easy as boarding a ferry. 90 minutes later, we arrive in Avalon, one of only 2 settlements on Catalina Island. I head on over to Catalina Scuba Love Dive Shop and pick up some scuba tanks. Then it's off to Casino Point for a shore dive. Casino Point is a beautiful spot just outside the harbor. It's also a marine reserve, so no fishing is allowed. I waste no time and start suiting up to explore this dive site that has such a great reputation. Casino Point is set up as a dive park with a protected area just for divers, safe from boat traffic.
And look, a staircase right into the water.
I walk down the steps and descend into the Pacific Ocean. Immediately, I am greeted by blue water, excellent visibility, and lots of kelp. And now I know why they call these places kelp forests. The kelp grows up from the seafloor as tall as trees. I really do feel like I'm in a forest. Kelp is a kind of marine algae that can take many forms. The kelp forests around Catalina Island are formed by giant kelp, which can reach the height of a 14-story building in only a single growing season because it can grow 2 feet a day. It's one of the fastest growing organisms on Earth. Looking down at it from above, I see what an eagle might see flying over the trees in a forest. But unlike trees on land, the kelp doesn't have a rigid trunk to hold it up. In fact, the kelp is quite floppy. So how does it stay vertical? At the base of each leaf, called a frond, is a pneumaticist, basically a little gas bladder. Each one of these pneumaticysts provides buoyancy, so the kelp floats. Down on the seafloor is something called a holdfast. Basically, it's like a set of roots that hold onto the rocks. Kelp needs something heavy on which to attach itself. It can't grow in a sandy seafloor. So, between the pneumaticysts keeping it afloat and the holdfast keeping it from floating away, the kelp hangs vertically in the water. Kelp is really important in this ecosystem because it's a great place to hide. And I don't mean for divers. This is a great habitat for fish to seek refuge from predators, so the kelp forest is filled with thousands of fish. The most famous kelp forest resident in Southern California is most certainly this damselfish, the Garibaldi. Garibaldis are hard to miss. No other fish in the kelp forest is quite so brightly colored. Although Garibaldis become aggressive when they're guarding a nest of eggs, the rest of the time they don't seem bothered by divers much. In fact, this one seems positively curious. I find it hard to film the kelp because every time I settle down to get a shot, a Garibaldi pokes its head in to see what I'm up to. So I film the curious fish for a few minutes, only to discover a whole bunch of other fish watching the show. It seems I've become quite popular down here. Because lots of divers come to this site, these kelp bass are not afraid. They must know that there's no fishing allowed in this sanctuary. They pose confidently for my camera. Nearby, I also find a turban snail. These snails move up and down the stipe of the kelp, munching away on the algae. All this munching is making me hungry, so as my tank gets low, I turn around and head back to the steps. Time for some lunch. The The following morning, I board the Catalina scuba love boat King Neptune. We're heading out to visit a different kelp site in hopes of finding some additional residents of the kelp forest. We leave Avalon Harbor under a beautiful blue sky. Only half an hour from the dock, I prepare to dive. The water's in the mid-60s, so a 7mm wetsuit will keep me nice and warm. I hop into the water from the dive boat's convenient submerged swim step, and Julia hands me my camera. I descend into the blue and soon enter another mysterious kelp forest. I head out deeper to a sandy slope where there isn't much substrate for the kelp. At a depth of 90 feet, we discover a rare resident of the kelp forest, a torpedo ray. I move a piece of kelp so I can get in close for a shot. The ray is not afraid of me because she has a powerful means of defense: electricity. This animal generates an electrical charge of nearly 50 volts that it can use to zap predators or its prey. The torpedo ray has a curious-looking tail, unlike most other rays. I want to see her swim so I can film the tail, so I give her a little tickle. The ray immediately turns around and faces off against my camera. I wasn't expecting such an aggressive reaction, so I keep my camera between the two of us and we stare each other down. I'm not making any sudden moves, and neither is she. But as cameraman Todd moves in closer for a shot and inadvertently closes her avenue for escape, the torpedo ray panics and attacks my camera, pulsing the muscles in her abdomen that create electricity. Then, as quickly as it began, she calls off the attack and swims away. I follow along behind, and now I can see how she swishes her tail back and forth to swim like her relative, the shark. Much different from how other rays swim. What a way to end an incredible couple of days diving Catalina Island. These beautiful forests of kelp and their colorful inhabitants truly are one of the many wonders of the blue world.
Don't go away. Jonathan explores some well-preserved shipwrecks in the St. Lawrence River.
The St. Lawrence River is one of the busiest waterways in the world. Because it connects the Great Lakes to the Atlantic Ocean, the river has been used for hundreds of years to get cargo to and from ports serving both the United States and Canada within the Great Lakes. Huge cargo ships travel up and down the St. Lawrence by the hour. Like any busy waterway, the St. Lawrence has had its share of accidents, and as a result, there are hundreds of shipwrecks on the bottom of the river going back hundreds of years. Many of these wrecks are remarkably well-preserved time capsules of history. To learn more about these wrecks, cameraman Todd and I have driven up to the Thousand Island region of the river to do some diving. The Thousand Island region is a beautiful community in upstate New York. There really are over 1,000 islands on the river here, and many of them contain incredible homes. Our guide to the area is famous National Geographic photographer David Duboulet. He's a local resident and expert on the nearby wrecks. We load the boat, operated by Chris Hunt of Hunt's Dive Shop, and we're off on an adventure.
Yep.
It's a little bit strange for me to be heading out for a dive in fresh water. It smells differently from the sea, and the conditions on the river are calmer than I'm used to. Chris expertly guides the boat to the first mooring we're visiting today. The bow of his boat tilts down like the front of a World War II beach landing craft, providing an easy entry into the water. We suit up, preparing to jump into the relatively warm 65-degree water. David and I head down the mooring line to the top of the wreck of the Keystorm in only 35 feet. The Keystorm was a 256-foot-long steel-hulled cargo ship that sank in 1912 carrying a load of coal. The captain miscalculated his position and struck a ledge. David knows this wreck well, so he motions for me and Todd to follow him towards the bridge, which is strangely on the side of the wreck. The ship is awkwardly lying on its side, so the bridge, instead of being the highest point on the wreck, is hanging out in space at a depth of about 60 feet. It makes for a great shot, and I explore the bridge, swimming in and out of the windows, the glass from which is long since gone. David photographs a ladder going sideways. I head upwards into the interior. Fish are hanging out inside, and rooms are full of deep accumulations of shells from generations of zebra mussels. Back outside, I swim a little deeper down the side of the wreck to a huge cowl vent. This is sticking up off the top deck, but since the ship is on its side, it points horizontally out into the water. A cowl vent is used to funnel fresh air below deck. Just to illustrate how big this thing is, I hop inside. Will I fit? Yes! Even with my scuba gear, I could slide right through this thing. Soon I'm off into another room. This used to be a stateroom where a member of the crew slept. Rust sickles hang from a doorway. And hanging vertically from the sideways floor, a bathtub! I hop in the tub for a quick rust bath, and then Todd and I head back out into daylight. David is swimming along the hull, which is completely encrusted in zebra mussels, a small invasive mollusk that grows on everything in the St. Lawrence these days. Finally, getting low on air, it's time to head back to the surface.
Woo! Wow. The really confusing thing about that wreck is that it's on its side, and so everything is discombobulated. The floors are the walls, and the walls are the floors of the ceilings. And when you're swimming through it, it doesn't make any sense at all. It completely throws your brain for a loop. But a very interesting dive visually.
We leave the mooring and head off to another wreck. Approaching Dark Island, home of Singer Castle, we slow and prepare to dive the wreck of the America. The America was a drill barge that sank in 1932 due to an accidental explosion of dynamite it was carrying. Several people were killed in the explosion. David, Todd, and I jump into the water and head down to the sea floor. In the shallows, we find the anchor chain and follow it over and down to the wreck. Once we reach the wreck, David directs us toward the stern where the explosion happened. As we approach the stern, it gets deeper and darker. At 75 feet, we encounter the props. Because the ship is upside down, the props are sticking straight up. David and I maneuver for shots while Todd backlights the props with his video lights. Next, we drop over the side, down towards the sea floor. Hanging off the bottom of the wreck, which is actually the deck, is a huge, rusty winch wound with steel cable. I poke my head into the engine room door and have a look around. As this was a steam engine, it had furnaces for the boilers. One of the furnaces is open, and I can clearly see the bricks lining the inside. This is where coal was burned to boil water to make steam for the engine. The black soot from the fire is still visible even after 80 years on the bottom of the river. I head out of the engine room, up the line to the chain, and back to the mooring line. My exploration of both the Keystorm and the America offered a fascinating glimpse into history. Shipwrecks are time capsules of history. The moment they sink, out of sight to the rest of the world, they stop changing with the world above. Although they eventually rust away and disappear, in the meantime they allow divers to travel back in time, if only for an hour, to a world of the past.
Meet Jonathan Bird, one of the world's top underwater nature cinematographers. Traveling the world on assignment for all the major networks, he is an Emmy Award-winning authority on the underwater world. In freshwater or salt, reefs, wrecks, or caves, Jonathan documents the world beneath the waves. Welcome to the Blue World.
Arg! I be Blackbird the pirate! And welcome to me, barge?
How I ended up a pirate on a barge is an interesting story. It all started back in 1717 when Edward Teach, better known as Blackbeard the Pirate, was roaming the Atlantic from Africa to the Caribbean, plundering ships as he went. Although reported by his crew to be a fair and decent man, Blackbeard had a fierce reputation, partly due to his clever use of lit fuses in his hat to intimidate his enemies. Off the island of St. Vincent, Blackbeard and his crew captured a French merchant vessel and quickly converted it to a pirate ship with 40 cannons, renaming her the Queen Anne's Revenge. She was Blackbeard's flagship in a growing armada of captured ships. But in 1718, Blackbeard ran the Queen Anne's Revenge aground on a sandbar outside Beaufort, North Carolina. Experts believe the grounding was intentional, the pirate version of corporate downsizing. He stranded many of his crew and fled in a smaller ship. Later that year, Blackbeard was killed in a battle with British forces not far away at Ocracoke Island. The Queen Anne's Revenge was lost for hundreds of years until being discovered in 1996. The shipwreck is now an active underwater archaeological site administered by the North Carolina Department of Cultural Resources. And that's where I come into the story. It's early morning in Beaufort, North Carolina, and I'm getting on a barge with a team of archaeologists. But not just any archaeologists. These are underwater archaeologists who are excavating the wreck of Queen Anne's Revenge. My good friend Rick Allen is in charge of all cinematography that takes place on the site, and today he'll be my underwater cameraman. Everyone sets up their gear, and it's time to shove off for pirate adventures on the high seas. As we head out under drawbridges, making our way from the inlet to the open ocean, Wendy Welsh, the project director, prepares for the day's work. It's going to be a long day as the weather has been bad and the team has lost a lot of time this week. So we have a lot of scuba tanks. Wendy talks with nautical archaeologist David Moore, whose research originally helped pinpoint the location of the wreck.
If you can get it, Rick, take it up.
Soon we arrive at the wreck site, and the barge is anchored directly above it.
All right, it's been a while since we've been out here, so we got some work to do today, so I hope you guys are ready to go. The way we left the site was we have both of our big dredges that are laying on 70 stake, and which is what our double boobies are, and then we have our frames that are on the pile. What I want to do first is get 2 divers in, kind of do a site assessment, see what's going on.
The first team suits up to check on the wreck and the visibility. The water is not known for clarity here in this shallow, sandy area.
The archaeological team needs to be able to talk to each other underwater so they can get things done. So they're all wearing these full-face masks, which have communications gear in them. You can talk by pushing this button, and you can hear what other people are saying through this little earpiece. So I'm going to be wearing one too, and I'll be able to talk to everybody and hear what they're saying.
We get in.
Yep.
Go to the bottom.
Yep.
Get comfortable. We'll follow the hoses down.
Rick and I have a quick discussion about our dive plan, and then it's time to see this wreck for myself.
Yeah, baby. Woo! You ready?
Jonathan, this is topside for a comm check.
I hear you loud and clear.
Copy that. Thank you, Jonathan.
The visibility on the bottom is terrible. I can barely see 4 feet. It's hard to describe how difficult it is to work in such bad conditions. Eventually, I find my way to one of the only landmarks on the wreck.
This is the North Anchor, the largest anchor on Blackbeard's ship. It's about 13 feet long. That's as big as a car.
Soon, the crew fires up the pumps on what is essentially a big vacuum cleaner called a dredge. Down on the bottom, this equipment is used to clear sections of the wreck by vacuuming up the sand that continually accumulates. I'm using the vacuum to clear an area around an object, but I have no idea what the object is.
What is this?
I'm not sure. It might be part of a cannon.
To me, everything we uncover looks like a rock, but to an expert, these concretions, as they're called, are treasure. While most of the wood on a shipwreck is consumed by the sea, metal, glass, and ceramics often survive. But hundreds of years of marine growth like barnacles and oysters add layer after layer of concretions on the artifacts. It takes an expert eye to identify artifacts in these rock-like concretions. Up on deck, the water and sand from the dredge go through a sluice where larger objects are sieved out and heavier particles settle out. There's all kinds of good stuff in here that we'll go through later. Down on the bottom, I know we're digging out something big.
What are we digging out here? Is this a cannon?
This is an anchor. There should be a cannon right next to it, a little deeper buried down.
Wendy has joined us in the water and enlists my help to take some electrical readings. The cannons, which are made of iron, produce a tiny electrical current as they corrode. Wendy wants to measure the voltage they're producing as a way of learning how fast the corrosion is taking place and which cannons should be excavated first. Our first step is to gently drill a hole through the marine growth on a cannon to reach the metal. Then I apply an electrode.
All right, so Jonathan is holding the electrode. You can start in 2 minutes and let him know when it is complete. Copy that, Wendy. Start 2 minutes now.
Okay, start the reading on the concretion for C7.
I have to hold the probe on the cannon for 2 minutes to allow the reading to stabilize. Then they record the reading up on the barge. After doing that for an hour, I feel like a real archaeologist. I'm a regular underwater Indiana Jones. But soon my tank is getting low and it's time to go back to the surface.
Wow! What do you think of that? Man, you know, normally I'm not a fan of vacuuming, but vacuuming a cannon out of a shipwreck is really fun. Isn't that neat? Yeah, I got a lot of sand in my gloves. That was great.
After a long day at sea, we finally turn and head back to the dock. But my work is far from done. My next stop is the Queen Anne's Revenge Field Lab, where archaeologist Lisa Briggs is panning for treasure.
Hi, Lisa. Hey, Jonathan, welcome.
Thank you.
Come on in. This is our field lab. This is where we're doing the micro artifact extraction.
At the field lab, Lisa's looking through all that sand and sediment we collected in the sloughs for micro artifacts.
We find all sorts of tiny little artifacts that would be overlooked if we were to look on site or underwater. It's really difficult to identify things perfectly underwater. We've got low visibility, we've got lots of currents, lots of stuff going on when we're actually underwater. So we save all the sediment, we bring it back here, and then we process it to try and find the tiny little cool bits of treasure that we missed when we're actually physically digging underwater.
The most common micro artifact on the wreck is lead shot, tiny lead balls that would have been ammunition for muskets.
Some of the shot that we find was actually used in handheld muskets and smaller handheld firearms. And then some other shot that we're finding, even the very small pieces, grape shot or seed shot, would have been used in bags inside of cannons, and that was used mostly to try to take out the rigging of an enemy's ship.
Lisa gives me a lesson in panning through the sand to separate the heavier lead from the lighter sand and rocks. It's a very similar technique to panning for gold.
You know, if it doesn't work out as an underwater archaeologist, I can go gold prospecting after working on this site.
We're gonna find you in Alaska next year.
Oh yeah. I actually pick up the lip a little bit.
Like something like that. I'm gonna starve if I have to feed myself with finding gold this way.
Finally, after I get the technique down, I find something.
I don't know. Oh, I think I see something.
There be lead in this here pan. Look at that.
We have found in total, I think, over 250,000 pieces of lead shot.
Now, you might not think of lead shot as treasure, but for a pirate, ammunition is critical. And to an archaeologist, this stuff is like gold. I spend hours sifting through the sand for micro artifacts, and I've become pretty good at panning for lead shot. But now it's time for my next stop.
Let's get out of here before she makes us do any more.
Not far from the field lab, tucked away in a warehouse, is the Queen Anne's Revenge Restoration Lab. I meet up with project director Wendy Welsh for a tour.
Hey, Jonathan, welcome to the lab.
Wendy, how are you?
Hey, nice to have you.
Inside are tons of artifacts that have been rescued from the shipwreck, all awaiting restoration so they can be put on display.
This is the North Carolina Department of Cultural Resources Queen Anne's Revenge Conservation Lab. And what we do here is we take in all the artifacts that come in from the QAR shipwreck, put them in storage, we conserve them and make them ready for public display, and everything in between.
Show me how you do that.
All right, so we've been out to the site and you've seen kind of what it looks like. You've seen a site map, and so the way these things come up are in large amorphous lumps called concretions. And what we do here immediately is, of course, store them in wet storage.
All of the artifacts are stored in tanks filled with water. They're being treated with special chemicals and an electric current to drive the salt molecules out of the metal. Without this process, these ancient artifacts would crumble into dust when they left the water. Everything from the tiniest brass fitting to the largest iron cannon has to be slowly, painstakingly treated with this process. And for a large object like a cannon, the process can take years.
So let me ask you, just out of curiosity, if you took a cannon out of the water,
all right,
and you didn't do anything, you just was like, hey, check it out, we found a cannon, and you brought it out and you maybe cleaned off all the marine growth and just put it in the museum, what would happen?
Well, it looked pretty cool for like the first 2 days. And then the first few days after that, it will start to rust. And then those salts that have been permeating that iron for many, many years is going to start to crystallize, right, as it dries out. And once that happens, it'll start popping off surfaces. And then you pop off your surfaces and you have no more nice, pretty cannon anymore. So that's why we have to do our process that we do. And it does take a good while, but it's actually a payoff in the end. If you think about it, our cannon were underneath submerged for almost 300 years. To get it into a conservation lab for it to take 5-6 years to be complete, that's actually not a bad ratio.
Right.
Next, Wendy shows me the largest artifact the team is restoring. It's so big, they had to build a huge custom tank for it.
This one, I'll go on the other side, and you might want to just pull it back that way.
We pull off the cover to reveal an anchor.
This is the anchor that we recovered from the site last May. It's 12 feet long and about 9 feet wide.
After seeing some of the artifacts being preserved, Wendy shows me how they get them out of the concretions. It starts with an X-ray of the concretion so the archaeologists can see exactly what is inside them before they start doing any work. This concretion has a couple grenades in it, as well as a number of other items. The X-ray clearly shows the location of the smaller artifacts buried within the concretion.
So this is an air scribe, and I'll turn it on, and hopefully it won't hurt your ears.
Next, using an air scribe, Wendy demonstrates how the marine growth is slowly cut away from the artifacts ever so carefully. Using this technique, over time, thousands of artifacts have come out of concretions, preserved and ready to go into an exhibit. In fact, right now there are more artifacts than there is space to display them.
But this is what's to come as far going into the museum next. So hopefully you'll see some of these on display soon enough.
I head on over to the North Carolina Maritime Museum to check out the Queen Anne's Revenge exhibit, where some of the coolest finds are on display for the public to see. There, I meet up again with nautical archaeologist David Moore to learn about the exhibit.
And what we're seeing here in just this small space is literally the tip of the iceberg. We've got some 300 unique artifacts just in this one area. Of the material that's been brought up, which is approximately half the site, we've only probably seen maybe 10% of that material. And of that 10%, maybe 5% has been conserved. We're looking at a fairly large volume of some very fascinating material that's going to be coming to light over the next decade to 2 decades of work in the laboratory.
These amazing artifacts now on display have not only shed light on the life of the world's most famous pirate, but also on the day-to-day happenings on a sailing ship in the 1700s. And they're here in a museum for all to see and enjoy. Through the dedicated work of these archaeologists, underwater, on the water, and in the labs, Blackbeard's ship is being slowly excavated, conserved, studied, and displayed for future generations. Even though I have only seen a small part of the process, I've come to understand and appreciate just how much work and dedication this project has taken.
Arg! Well, I spent me a day with the Queen Anne's Revenge team. I came out looking for treasure. But what I discovered is the treasure is the ship.
Don't go away. Jonathan investigates a group of hungry manta rays that follow divers.
Manta rays are the world's largest and most graceful rays. They are completely harmless to people and often even curious of divers. I have filmed them at cleaning stations in Yap in Indonesia, feeding in large aggregations in the Maldives, eating grouper eggs in Florida, and hunting alongside the whale sharks of Holbox, Mexico.
But here on the big island of Hawaii, the manta rays do something amazing.
My adventure begins at Big Island Divers in Kona. Down at the marina, I board the boat for a unique experience unlike anything else in the world.
Good? Yeah, I'm ready when you are.
We have a short boat ride to the dive site. We arrive at a small cove where other dive boats are gathering, waiting for the sun to set. My guides to this dive will be Danielle Woolen and Jonathan Davis, who have each done this dive thousands of times. Soon it becomes clear how popular this dive is. Nearly 20 boats have shown up as darkness falls. As much as I'm tempted to jump in, I must be patient. The action here begins after dark. Finally, the sun sets and people start suiting up. As snorkelers go into the water, their flashlights create an alien glow. It's time for me to enter the water and see what's going on beneath the surface. I swim over towards the commotion, and soon I see a manta ray. Then another. They are feeding in the lights of the snorkelers at the surface. As I sink down below, I can see groups of divers holding their dive lights pointed towards the surface. The mantas are feeding in the light of their lights too. Just as a light attracts insects at night above water, light attracts plankton at night underwater. So after a while, bright lights attract a lot of plankton, and the manta rays come in to feed on the plankton. The whole ocean is lit up, so a lot of plankton swarms into the bay. While mantas have huge mouths wide open as they pass the divers, nobody's in any danger. These massive animals, which can reach 18 feet across, the size of a car, eat only plankton. They catch plankton with strainers in their huge gills. Water goes in through the open mouth and back out through the gills at the back of the throat. But plankton gets stuck in strainers called gill rakers in the gills. Every once in a while, the manta closes its mouth and swallows the plankton. On each side of its mouth is a fin called a cephalic lobe. Mantas used to be called devil rays because these fins look like demonic horns. As it turns out, they're actually used for feeding by helping to funnel more water into the manta's mouth as it swims. So how did the mantas learn to feed in the light of divers? It all started back in the late 1970s at a nearby oceanfront hotel. The hotel has lights to illuminate the ocean for the guests. With lights shining on the water for many years and plankton accumulating under them every night, eventually manta rays discovered this nightly hotspot for feeding. Soon people realized that mantas regularly visited the site and scuba divers started going out to see them. The first manta ray to be documented at the site was a female with a damaged left cephalic lobe. She may have been attracted to the light because her damaged fin makes it harder for her to catch food on her own. She was affectionately named Lefty by the divers. Now, over 30 years later, there are over 200 individual mantas known to frequent the site. And guess who comes over to pay me a visit? Lefty herself! She does a close pass over my bright video lights and then comes around again. This goes on for the entire dive. Nobody is quite sure how long mantas live, but Lefty has to be at least 34 years old since she was first seen in 1979. I'm starting to feel a little bad about hogging all the mantas because my video lights are so much brighter than a plain old flashlight. I have a huge amount of plankton swarming around my head and the mantas can't get enough. Divers are asked not to touch the mantas because being petted and touched night after night is bad for their skin and the thin layer of mucus that protects it. Yet, many of the mantas have pink, irritated skin on their cephalic lobes and chins caused by rubbing against the dive lights every night as they attempt to scoop as much plankton as possible. There isn't much I can do about the mantas bumping my lights and camera except to try to pull it back a bit as they swim over. Most of the time it works, but not always. As the night goes on and the other divers slowly start to leave, more and more mantas come to my video lights. Soon, cameraman Todd and I have them all to ourselves. It seems like the mantas would probably stay here all night if we did. Unfortunately, just like the other divers, we soon get low on air and need to think about heading back to the boat. Reluctantly, I leave the bottom, keeping my video lights on so the mantas can see where I am. I don't want a dozen mantas crashing into me as I ascend. By swimming slowly, the clouds of plankton are able to follow my lights, and so do the mantas, trailing behind me like hungry puppies. Up in the water column near the surface, the mantas start taking turns doing barrel rolls in my lights, which keeps their mouths right in the highest concentration of plankton. All too soon, however, I reach the stern of the boat and need to get out of the water, leaving my hungry new friends in the darkness. Soon the plankton will dissipate and the mantas will have to go back to their normal nighttime routine.
Honestly, there's really no better way to describe that dive than pretty much the most amazing thing I've ever seen in my life. I mean, we're talking about dozens of manta rays all feeding within inches of my head. It's just incredible to see something I'm never gonna forget. In fact, they're right back at the back of the boat.
As we head back to the dock in darkness and I think about the spectacular dive I just did, I realize one thing for certain. I know what I'm doing tomorrow night.
Meet Jonathan Bird, one of the world's top underwater nature cinematographers. Traveling the world on assignment for all the major networks, he is an Emmy Award-winning authority on the underwater world. In freshwater or salt, reefs, wrecks, or caves, Jonathan documents the world beneath the waves. Welcome to the Blue World.
An ecosystem is a community of organisms living together in balance with each other. In theory, a balanced ecosystem will stay balanced and healthy as long as nothing interrupts the harmony of the interrelationships between all of the organisms. Many things can throw the balance of an ecosystem out of whack. For example, overfishing can remove certain animals from a reef ecosystem, creating a gap in the food chain that causes the whole ecosystem to suffer. But another increasingly common disruption of ecosystems comes in the form of invasive species. An invasive species is an organism that has been introduced into an ecosystem from somewhere else, often causing a change in the balance of that ecosystem. Perhaps one of the most well-known invasive species in North America is the zebra mussel. This harmless-looking mollusk lives in fresh water.
They call them zebra mussels because of the zebra-like pattern on the shell.
The zebra mussel has invaded the Great Lakes, St. Lawrence River, and numerous smaller lakes and ponds around the United States and Canada. It was brought from Europe as larvae in the ballast water of ships. When a cargo ship travels with a proper load, it settles down into the water to the depth for which it was designed. But sometimes on the return journey there isn't enough cargo, and the ship floats too high in the water, which isn't safe. So the ship has tanks called ballast tanks, which are filled with water to weigh the ship down. When the ship arrives at its destination, the ballast tanks are emptied. Sometimes the water carries tiny planktonic invaders from another country, which are inadvertently released into the environment. Since cargo ships go up and down the St. Lawrence on their way from all over the world to the Great Lakes, ballast tanks are a big issue. The zebra mussel was first detected in the Great Lakes in 1988. Because it reproduces so quickly, within only a few years, everything in the Great Lakes was soon covered in a layer of zebra mussels. While the zebra mussel might not seem like much of a threat, they grow so densely that they clog the water intakes of hydroelectric power facilities, the hulls of boats and ships, docks and buoys. It's estimated that the annual cost to control them in the Great Lakes exceeds $100 million a year. Having never seen a zebra mussel, I head up to Clayton, New York to visit the beautiful Thousand Island region of the St. Lawrence River. I join David Dubélé, the famous National Geographic photographer, on a shore dive in the river to check out the mussels. David lives nearby, and this is practically his backyard. We're diving an old wooden-hulled shipwreck called the Islander right near shore. As soon as I sink beneath the waves, I see zebra mussels attached to the wreck and the rocks on the bottom. Zebra mussels haven't been all bad, at least from a diving point of view. Because they eat by filtering plankton from the water, zebra mussels have massively improved the underwater visibility in the river and the Great Lakes by removing so much of the plankton that clouds the water. As I examine the bottom of the river, I start to notice that the rocks are moving. Wait a minute, those aren't rocks, they're fish! And they're not just any fish, they're round gobies, another invasive species. Round gobies also came to the St. Lawrence from Europe in ballast water. Round gobies are so good at eating and reproducing that their population has exploded in the St. Lawrence. These little bottom-dwelling fish are everywhere you look. Why have they done so well here? Guess what they love to eat? You guessed it, zebra mussels. But it's not all good news. The round goby also eats the same crustaceans, worms, and insect larvae that are food for native species like sculpin, so they're out competing the local fish for resources. On the flip side, it turns out that larger fish like bass, walleye, salmon, and trout all love to chow down on round gobies. The result? The influx of round gobies has fueled a comeback in several depleted species of larger fish. 1,500 miles away in the Caribbean, another invasive species is making waves. The lionfish is a beautiful but deadly invader. This venomous fish has spines that act like syringes filled with a deadly toxin. Because of the excellent protection afforded by the spines, very few animals can actually eat a fully grown lionfish. A fish native to the Indo-Pacific, the lionfish was thought to have been introduced to the Caribbean in the 1980s by people releasing lionfish from the aquarium trade. 30 years later, there are literally millions of lionfish in the Caribbean, and the population seems to be growing unabated. Lionfish are voracious predators. A single individual can eat dozens of fish a day. And that's the problem. People are concerned that they're eating up all the other small fish in the Caribbean, and no predators exist to control their population. Another opinion, however, suggests that the fish have only been able to take over so easily because they're occupying a niche in the food chain that was vacant due to overhunting of other species like grouper. These critics argue that nature will eventually control the lionfish population itself through prey availability. To learn more, I head on down to St. Thomas in the U.S. Virgin Islands. At the Coki Beach Dive Shop, I hook up with local dive guru Peter Jackson. We head down to his boat and load our gear. We push off the dock and head out to the dive site. This is no ordinary dive, though. We're meeting up with a group of divers from the Core Foundation, an organization that is attempting to contain the lionfish explosion in the waters of the U.S. Virgin Islands. I gear up to join the Core Foundation on a dive. Underwater, I follow divers Kitty Edwards, John Rubatino, and Jason Kittel as they scour the reef looking for lionfish. As it turns out, lionfish are not hard to find. In fact, they're just about everywhere. Jason takes aim with his spear gun and snags a lionfish. Carefully, it's placed into a tube. The spines are still quite dangerous even after the fish has been speared. Just about everywhere I look, there are more lionfish. The core team misses a few, but they manage to bag more than a dozen lionfish on a single dive. Unfortunately, this doesn't even put a dent in the population of lionfish at that one dive site. Following the core team has shown me just how invasive these fish are. I really don't think there's any stopping them in the Caribbean at this point. Back on shore, they measure and pack up the fish. They're going off to a researcher who will analyze the stomach contents to see what they're eating. As international shipping and transportation increases all around the world, plants and animals are able to hitch rides and travel to places they never existed in the past. These invasive species affect change in the ecosystems they invade. It's not always harmful to the environment, but one thing has become obvious. Invasive species are extremely hard to remove once they've been introduced and may in fact become a permanent addition to a local ecosystem, like it or not. So when it comes to invasive species, it seems that the best and perhaps only solution is to prevent the invasion in the first place. Scuba diving is more than just an exciting sport. It's also a very effective way to explore the underwater portions of our planet and even conduct scientific research. But it has one limitation: depth. Traditional scuba gear has a practical depth limit of about 200 feet. As a result, we know very little about life beyond this limit because exploration in deeper water is so much more difficult.
But you know me, I always have a plan. Today I'm going to explore the deep waters around Cocos Island in a submarine.
This isn't just any submarine. This is the Deep Sea, operated by the Undersea Hunter Group off the support ship Argo. It can dive to over 1,000 feet. Our team is 300 miles off the coast of Costa Rica at Cocos Island. It takes 30 hours just to get here. This uninhabited speck of paradise in the Pacific Ocean is filled with waterfalls and lush rainforest. Anchored in the calm lee of the island, the Argo is my home away from home for a week. The waters around Cocos feature steep drop-offs filled with fish and sharks. Hammerheads come here to be cleaned of parasites and dead skin by legions of hard-working butterfly fish. Sometimes the water above is filled with shivers of hammerheads. Occasionally, the world's largest fish makes an appearance. I get lucky when a whale shark passes by. But I want to see what's way down deep, and to do that, I'll need that submarine. My adventure begins with a safety briefing. Samuel Bloom, known to his friends as Shmulik, gives me an introduction to the emergency features of the submersible. Shmulik is the manager of the sub operation and the chief pilot. Next, I weigh in. In order to load the correct amount of ballast in the sub, they need to know the total weight of everything in it, including the passengers. It's a little tricky to get an accurate reading on a rocking boat. Next, it's time to change into my blue submarine jumpsuit.
Everybody in the sub wears a blue jumpsuit to minimize reflections in the dome because the water outside is blue too.
While I'm getting my briefing, the sub is being launched. They keep it out of the water for safety until just before it's time to depart on a mission. That big sphere on the front is where the people go, and it affords a wide view of the underwater world.
Okay, red handle, I see that.
Now it's the moment of truth. Time for me to climb into the sub. It has started to rain, so the crew has placed a rain cover over the sub to keep water out of the cockpit. Once I finagle my way into the cramped cockpit, the crew closes the dome and latches it down, sealing it shut. Inside, Avi, the pilot for today's mission, and Shmulik work through their pre-dive checklist. And outside, the crew prepares the sub for departure. First, we pull away from the Argo. Next, we're connected to a surface tender for a tow out to the dive site. This saves the batteries on the sub for the actual dive and also makes getting to the site faster. Shmulik is on the radio with the tender coordinating the mission.
Okay, so we are going with the current right now, correct?
The first time you guys drove this thing, did it completely freak you out that there's water at the bottom?
It's actually, we start to freak out when the water gets to our feet.
It's a very strange feeling to be sitting inside what is essentially a half-submerged fishbowl in the ocean. And the conditions today are not particularly calm. It's a rough ride to the dive site. Soon, Jose, the diver, comes over to disengage our tow rope so we can submerge. Avi releases air from the ballast tanks and we start to sink. Soon we slip beneath the waves. Shmulik waves goodbye to Jose as we sink away from the rough water at the surface.
I can't believe the amazing view out of the top of this submarine. I can see 360 degrees in all directions. It's incredible!
As we sink into the first 100 feet of water, the light coming into the cockpit gets really blue like the ocean. But there isn't much sensation of depth because there's nothing to see outside and there's no change in pressure inside. A school of hammerheads passes over, not concerned about the sub. Soon we reach the top of a seamount that the crew refers to as Mount Everest. It's one of their favorite dive sites.
We're at the top of Mount Everest, which is actually a huge rock. The bottom is 300 feet deep and the top is 150 feet deep. The currents, the deep water currents, come along and they hit this rock and they go up the side. They bring upwelling and nutrients with them, and it's a great place for the fish. They love to hang out here, and we're just hiding behind the rock, checking out the fish.
As we reach 67 meters, a little more than 200 feet deep, the rock outside is covered in a beautiful octocoral that only grows in the cooler water down here. We film it with the sub's built-in camera system. I look up, and passing over the summit of Mount Everest is a whale shark. The shark turns and makes another pass by the sub, so Avi drives the sub right alongside the shark for a close-up view. Many times in my life, I've exhausted myself trying to keep up with a whale shark. Doing it in a submarine is almost too easy. But if we spook the shark, there's no question it can get away from the sub. This sub is nowhere near as fast as a whale shark. Avi does a beautiful job of following along behind the shark while Shmulik films. Impressed by Avi's abilities driving the sub, I had to learn how it's done.
Explain these controls to me here.
We have the joystick here, which controls all the maneuvers of the sub. This is forward, backwards, side, and up and down, and then we can crab sideways with this, and then we can decide how much power we want to give to the thrusters.
Heading back to Mount Everest, we encounter a Galapagos shark passing by the sub at a depth of about 200 feet. Even though we're now well beyond the limits of sport scuba diving, all the fish still look like the fish I'm used to seeing on my dives. When we reach the bottom of Mount Everest, we've arrived on a shelf at a depth of 300 feet. Avi and Shmulik are navigating using sonar, which shows the shelf, the seamount, and the drop-off where we're heading.
Well, I'm at 300 feet, officially the deepest I've ever been. But what's really amazing is there's still light. It's dark, but it's not completely dark. And look at how much marine life there is at 300 feet.
Even at 300 feet, we still see schools of hammerheads above in the blue.
See how they're fighting the position there in the current?
As we sink past 400 feet, we come across a group of jelly-nose fish aggregating in the wall. Jelly-nose fish are only found in deep water, and very little is known about them. I've certainly never seen one before. They get the name jelly-nose because they have a cartilaginous skeleton like sharks, but they're not closely related to sharks. Virtually everything about these fish, including the purpose of this gathering, is a complete mystery. Nearby, a goosefish. Although there are species of goosefish that live in shallow water, this one is only seen down deep. It lies on the bottom, camouflaged, its huge mouth waiting for prey. Nearby, a colony of tunicates in the shape of a tube like a sponge. Crabs seem to be picking it over for food, but who knows what's going on? The deep sea provides more questions than answers. In the dim light, a mobula ray glides by the sub. The mobula is basically a small manta, and this species is frequently seen in shallow water. What it's doing down here, 500 feet below the surface, is anyone's guess. We're now at 218 meters, about 700 feet. From a distance, the bottom looks lifeless. Closer inspection, however, reveals tiny white cup corals. Who could imagine corals at 700 feet? But then, while concentrating on tiny little corals, something swims into our lights. A ragged-toothed shark. The ragged-toothed shark, also known as the small-toothed sand tiger, is only occasionally found in shallow water, but much more commonly associated with depths over 500 feet. Here at almost 1,000 feet, this shark is in its element. Down here, the light is almost gone, but a pale blue glow comes from above. And then, just as we pass 1,000 feet, the deepest shark I've ever seen. A prickly shark swims towards the lights on the sub. Prickly sharks like cold water, so they usually hang out down deep, but they have been seen in shallow, cold water in some places. I've certainly never seen one before. The shark is intrigued by the lights on the sub and comes towards us. All sharks have sandpapery skin due to their dermal denticles, but the ones on the prickly shark are particularly thorn-like, which is where this shark gets its name. The shark circles the sub several times before vanishing into the darkness. Soon it's time to head back to the surface, but along the way we stop again at Mount Everest for one task to be done before we leave. Shmulik has to use the mechanical arm on the sub to retrieve a remote temperature sensor. Inside the sub, he manipulates the arm with a remote control.
It's spinning, huh?
The temperature sensor has been down here for 6 months recording water temperature data for scientific research. Shmulik will use the arm to grab the sensor and bring it to the surface to download the information it has recorded. He lines up the jaws of the arm, and he has it.
Ooh, nice work.
Avi drives the sub back to the Argo underwater. We won't need to be towed home. Besides, the water at the surface is rough, and it's nice and calm down here. We slowly ascend right near the stern of the Argo.
Well, I made it back from the depths of the ocean, and I never even got wet.
And we can see that it has started to rain again, with raindrops appearing on the water above. With perfect accuracy, Avi has brought us right to the back of the ship. We bob around a little while Avi gets the sub aligned with the sub bay and the Argo. He will drive it right in, like putting a car in a garage. Jose jumps aboard and helps guide the sub the last few feet, and then we're back. The crew covers the dome to keep rain out when they open up the cockpit. And then I climb out.
Woohoo! Hey! I'm back!
My experience in the submersible certainly ranked up there as one of the most fascinating things I've ever done. And getting to see marine life far deeper than I can ever scuba dive was a once-in-a-lifetime experience. I can say for sure that while this might have been my first trip in a submarine, I hope it's not my last, because I really want to do this again someday. Who knows what we'll discover next time.